Welcome back, and let's continue from where we left off in the last video. In the previous video, we saw how to push images to OCIR repositories, and in this one we will take a look at how to pull images from OCIR repositories. Well, to do that you can simply use the copy pull command, which is available in each of the images. So currently we have selected the MySQL latest image, which is available in the public repo. Alright, so let me go ahead and click on the button which says copy pull command, and let me go back to my Cloud Shell terminal. And before I run the docker pull command, since we already have these images present in our local repository, let me first go ahead and clear the local repository. So in order to delete all the images that are present in my local repository, so let me go ahead and run the docker rmi command. That will delete all the list of images that are present in my local repository. Let me go ahead and hit enter. As you can notice, it has deleted all the images, and let me go ahead and reconfirm that using docker images command. So if you notice, currently there is no image in my local repository, right, in my Cloud Shell machine. Let me first clear the screen and let me paste the pull command we just copied for the MySQL latest image. Let me go ahead and paste it. So this is the docker pull command to pull this image from this particular path. We already know about the path, so let me go ahead and hit enter. And as you can notice, it's pulling the image from the public repository. And if you notice, it didn't ask us for any kind of authentication, right? Because it's a public repo and anyone with the access of your URL will be able to pull this image from the public repository. If you are having your images stored in a public repository, they'll be easily accessible to anyone on the internet if they have the path to your image. Well, as you can see, the pull has been completed successfully. Let me maximize the screen, and if I run the docker images command now and hit enter, you get to see that the image has been downloaded in my local machine, right, in my Cloud Shell machine. Well, now let's go ahead and try to pull the image from the private repository, which is our Nginx image, right? Let me minimize this and let's go to the Nginx image. Let me click on the image from the list. And here is the pull command to pull the Nginx image. Let's copy the pull command and paste it here in the terminal. Before I run the pull command for the Nginx latest image, which is residing in a private repository, let me quickly run a docker logout command to actually show you that what would happen if someone without logging in is trying to pull an image from the private repository. So let's run a docker logout command to log out from the container repository session, for which I'll be writing docker logout space phx.ocir.io and hit enter. So it says removing login credentials and I'm logged out from this particular container registry. And now if I just paste the pull command for my Nginx latest image, which is docker pull and the path to my Nginx latest image, and if I hit enter, basically it says anonymous users are only allowed read access on public repos. Now since the Nginx image that I'm trying to pull is from a private repository, I must first authenticate myself as a user of that repository. Let me do a docker login once again and mention the path to our container registry, which is phx.ocir.io, and hit enter. Well, for the username, as I already mentioned, it should be tenancy namespace / your username. So let me fill up the information. And once I enter the username, the next thing that it asks for is password, and password is the auth token, right? Let me go ahead and paste the auth token that I had generated earlier. All right, so let me go ahead and hit enter, and it says login succeeded. Now the next thing that I would do is rerun the pull command for my image, which is in the private repository. Let's go ahead and copy the pull command again and paste that command over here. And when I hit enter, as you can notice, it is able to pull the image now, and the pull has been completed. Now in my local repo, I have both the images. Let me do a docker images. And if you see that we have both the images, one from the public repository and one from the private repository. So we saw how to push and pull images to and from OCIR, and we also understood that creating a repository before pushing an image is the usual workflow, but it's not always necessary. Because if you are not authorized to manage repositories in the tenancy's root compartment, you must always push an image to an existing repository, which means you must create the repository first and then push an image to that repository. However, if you are authorized to push image to the tenancy's root compartment, then you can skip that part. It's not required that you have an existing repository. And to explain you, let's go to the settings. And in this setting, we have this option which says create repository on first push in root compartment. So basically what it says is if you push an image and the command to push the image, basically the docker push command includes the name of a repository that doesn't already exist, what it does is it will create a new private repository in the tenancy's root compartment and push that image in that private repository. So let's see this in action. Let me cancel this and let's restore the Cloud Shell terminal. Now let me clear the screen over here. Now let me first retag this Nginx image that we have in our local repository and change the repository name over here. So let me quickly do a docker tag command, docker tag space the image ID. It's BC64 for Nginx, as you can notice from here. And let me also give the target tag. So the target tag is phx.ocir.io / the tenancy namespace, which is int Orkel Rohit / the repository name. Now remember, the repository name that I'll be providing here does not exist in my tenancy. So let's give it a name. So I've given it a name oci-repo- does not exist / Nginx and with the version latest. Alright, so I have tagged the existing image to a new image name and let me go ahead and hit enter. And as you can see, it has returned the prompt, so there was no error in tagging. Now let me go ahead and push this image. Right, so I'll do a docker push and copy this path, paste it here. Now remember, there is no repository with the name oci-repo- does not exist in my tenancy. Let me also quickly show it to you. So let me go to the container registry and let me go to the root compartment. And if you notice, in the root compartment, there are no repositories, 0 repositories, right? And as I had already mentioned, the repository name are usually unique across all compartments in the tenancy, right? So we don't have that repository that exists in the tenancy in any of the compartment. So let me restore the Cloud Shell terminal and let's go ahead and hit enter. And once I hit enter, basically what it will do is, since that setting allows us to create a private repository in the root compartment, let me go ahead and hit enter and see if it does the same for us. Now, as you can notice, it says mounted from an existing OCIR repository. If we were trying to push the same Nginx image, it is very much possible that the OCIR has identified the image that already exists in one of our private repositories, and it is optimizing storage by linking the existing image rather than creating a new copy. And this behavior is often referred to as layer mount. So in container registries like OCIR, images consist of layers, and when an image shares the same layer as an existing one, the registry can save storage space by linking to those common layers rather than storing redundant copies. So let's minimize this and let's check here in the root compartment. Let me quickly refresh this page. Well, there you go. As you can see, the number of repositories has changed to 1, and from the list, we can see the Nginx latest image in the repository oci-repo- does not exist / Nginx has been created, right? So if I click the repository has been created, and within the repository, we have this image. Well, let me reiterate that you must belong to the tenancy's administrator group or have been granted the repository manage permission on the tenancy to automatically create the private repository in the tenancy's root compartment. Alright, so with this we come to the end of this demo where we saw how to push and pull images to and from OCIR We also saw one of the OCIR setting that allows us to push images to a repository that doesn't already exist in the compartments within your tenancy. I hope you found this demo useful. See you in the next one. Thank you so much for watching. Hello and welcome to this demo on managing OCIR. In this third part demo, we will be looking at how to manage images within OCIR. We will be covering a range of tasks including listing images, viewing images and image details, deleting an image, undeleting an image, unversioning an image, and finally we'll take a look at retaining and deleting images using retention policies. So let's get started. I'm back to my OCI console. Let's go to the container registry by clicking on the navigation menu. Let's go to the developer services and click on container registry. And let's select the compartment where you wish to list the images. So in our case, it's OCIR-OKE-demo compartment. And as you can see on the screen, it says we have two repositories in this compartment and there are two images, one in each of these repositories. How do you list images is basically you click here in the drop down menu and you can select the images available under each of these repositories. So let's say I click on Nginx image. Well, when I select the image, I get to see a lot of information about it in the information tab over here. And as you can see, we get to see who published this image. We get to see the OCID of this image. We get to see the image digest. We also get to see when was the image created and what is the total size of the image in MBs. And also we get to see how many number of times the image has been pulled so far and when was it last pulled. Well, that's the generic information about the image that we get to see. Now, when you click on the layers tab, you get to see all the SHA message digest of each layer in the selected image, right? So for the Nginx image, we have these many layers. So when you select the versions tab, you get to see the full path of the image along with the version identifier. And in this case, it is latest. Now, since the Nginx image that we pushed into this repository has only one version, that is latest, we get to see only one entry over here. But in case if we push more images with different versions, right, we get to see those many versions over here. And then we have the tags tab where you get to see the tags that you had assigned to the images. Since we had assigned no tags, there are no associated tags to this image. At the bottom, you get to see the signatures and the scan results tab. Basically, here you get to see the information whether the image was signed before pushing into the registry, or also you get to see the scan results if the scanner was enabled for this image to identify any sort of vulnerabilities in the image. Well, these are the topics that we'll be covering in another video as we progress in the course. And as I had already mentioned, you also get to copy the pull command that lets you pull this image into your Docker client machine. So you can always click on this button to copy the pull command. Well, that was about getting image details. Now let's look at how to delete an image from the container registry. When you no longer need an image or you want to clean up the list of image versions in a repository, you can delete them from the container registry. Well, of course, you would require permissions to control which images you can delete. And yes, if you belong to an administrators group, you can delete images from any repository in the tenancy. Let me quickly show you how to delete an image. So in order to delete an image, you need to first select the image from the drop-down list. Let's say I wish to delete the MySQL latest image. Let me select that. Now, before I delete this image, let me copy the image OCID and we will be seeing how to use the OCID later on. So let me copy it. And now to delete the image, simply click on delete image button and confirm your deletion. Let me click on delete. And as you can notice, the image count has reduced by 1. And within the drop down, again, we only see the repository, but there is no image present within the MySQL public repo. When I select the MySQL public repo, now that I've deleted the image, but still the size information in the repository says that there is 158.44 MB data available, right? So what is that? Basically, when you delete an image, it can take up to 48 hours for the deletion to take effect and for the storage to be released, which also means that you can undelete your previously deleted images for up to 48 hours after you delete them. Let's quickly perform an operation to undelete the MySQL latest image that we just deleted. Well, the task to undelete an image cannot be performed using console, for which we will have to go to the CLI and we'll have to use the OCI artifacts container image restore command, and the required parameter for the command is the image OSIT, which is why I had copied the image OSIT. So let's restore the Cloud Shell and let me quickly clear the screen over here. And let's run the OCI artifacts container image restore command. And the flag double hyphen image hyphen ID needs a parameter which is your image OSIT. Let's provide the image OSIT that we copied earlier. Let me go ahead and hit enter. There you go. So the image has been restored. Now let me quickly go ahead and show it to you in the console. Well, let me quickly refresh this page. Let me switch compartments. Let's go back to the OCIR-OK-demo compartment and let's check. Yeah, as you can see, the image has been restored. We get to see two images now. And from the drop down, we get to see the image can be seen over here. And if I click on the image, basically I was able to successfully restore the image. If you notice something over here, the version information is gone. So for a deleted image, and if you're trying to restore it, the version information will be lost, and the new version that the image gets is unknown at the rate the SHA-256 digest for that image. Well, this is how you undelete or restore a deleted image. So now let's look at how to unversion an image. What do you mean by unversion is basically when you want to clean up the list of images in a repository without actually deleting images. What you do is you remove the version identifier from the images. So let's go to one of the images. Let's say, let me select the Nginx latest image and let's go to the versions tab over here and simply click on remove version. So when I click on remove version, it will ask me for confirmation. Let me go ahead and select remove and it removes the version identifier from the image. Now when I click on the drop down, you will notice that the version identifier has been removed and now it says unknown, similar to the version identifier that it has for a restored image. As you can see, it says unknown for both these images now. I'm able to see both these images because this particular option is checked over here which says include unversioned images. The moment I deselect it and click on the repo and image list, as you can notice, it won't show up those images to me, right? So this is basically I'm not able to see the unversioned images, right? And it'll only show me those images that have been versioned. But in our case, both the images have now been unversioned. The moment I check this again, it will show me all those images that are versioned as well as unversioned. So this is another way of keeping list of images clean in your repository by simply unversioning them. Now let's take a look at retaining and deleting images using retention policies. We can set up image retention policies to automatically delete images that will meet particular selection criteria. Now, where do you find these retention policies? Click on the settings button over here and you get to see the global image retention policy as well as the custom image retention policy. Now let's talk about the global image retention policy first. Well, the global image retention policy's default selection criteria is to retain all images so that no images are automatically deleted. But we can change this global image retention policy so that the images are deleted if they meet the criteria that we specify. Let me go ahead and click on edit global policy. And as you can see, we haven't selected any deletion rule yet. The options that we can choose from is we can either select delete any images that haven't been pulled in the specified number of days. You can specify a criteria where OCIR deletes all those images that haven't been pulled for a specified number of days, and you have to specify the number in days over here. You can also go for delete any images that haven't been versioned in the specified number of days. If there are unversioned images in your OCIR repository, those will be deleted if they haven't been versioned in the specified number of days. Well, you can also exempt certain versions of images from being deleted. This is an optional thing. For example, let's say I don't want an image that has been versioned as latest to be deleted. I will write down latest in this box. We can also mention a number in terms of version, for example, 3.0.1, which must not be deleted when the global image retention policies take effect. Basically, it's an hourly process that checks images against the selection criteria that we have specified, and any of the image that meet the selection criteria are automatically deleted. And trust me, when it comes to manage multiple repositories and images within them, and manually deleting those images could be tricky. But if you have a global image retention policy in place, managing your images becomes much more easier. And also, let me remind you that the global image retention policy applies to all the repositories in the region unless it is explicitly overridden by one or more custom image retention policies. Now, what is a custom image retention policy? Basically, it is a policy that overrides the global image retention policy with different criteria for specific repositories in that region. How do you create one? Basically, if you notice over here, it says image retention override policies. You can simply click on add override policy over here, and this panel is where you provide the information. Let's give the policy a name. Let's say custom OCIR policy, and then you must select the policy that you wish to apply. Let's say delete any image that haven't been pulled in the specified number of days. Let me make it 2. And let's say delete images that haven't been versioned for a specified number of days. Let's say 15. And you can also provide exempt versions and click on save changes. Now that I have created the custom OCIR policy, I will have to add repositories to it. Simply click on edit override policy over here, and when we scroll down, you will notice that there is an associated repositories section. Here you need to specify the repositories that will be associated to this policy. Let's click on add another repository over here, and let's select the repository that we wish to associate with this policy. So let's select the Nginx repo, and you can also select multiple repositories by clicking on another repository and select another repo. Let's say I select both my repos. You can also change compartments to select repositories that belong to some other compartment within your tenancy. For example, if I click on change compartment and let's say I select the one in CityDoc, right? So from the CityDoc compartment, you can select a list of repositories where you wish to apply this custom image retention policy. So let me go ahead and select one of the repositories and click save changes. And let's go back to the settings. And if you notice, we can see that these are the 3 repositories on which the custom image retention policies applies. So remember, going forward, the custom image retention policy will override the region's global image retention policy, and the images in the repository will be deleted from the container registry if they meet the criteria specified in the custom OCIR policy that we just created. Also remember, when you create or update an image retention policy, there's an hourly process that checks images for deletion, which will ignore the new or updated policy for several hours. With this, we come to the end of this 3-part demo series on managing OCIR, where we saw how to create repositories, how to manage those repositories. We also saw how to manage images within those repositories, and we looked at different settings such as global and custom image retention policies. I hope you found these demos on managing OCIR useful. See you in the next lesson. Thank you so much for watching. Hello and welcome to this lesson on Introduction to Container Instances. I am Mahindra Mehra and I am a senior training lead and evangelist with Oracle University. So let's get started. Meet Alex. Alex wants to test his containerized application, but without deploying it on the OKE as the scale is not large. At the same time, the application he wants to containerize are running isolated web applications or RESTful APIs. He is also looking for a simple, quick, and a secure way to run containers without managing any servers. One way for Alex to run his containerized applications without using Kubernetes is to provision a virtual machine, install container runtime, and run the application on it. But this process still increases the operational complexity as it would require him to manage virtual machines and servers, patch the operating systems, and update the container runtime regularly. Containers have become the favored method of packing, deploying, and managing modern applications. Among container solutions, OCI Container Instances offers the quickest and the most straightforward way to launch containers. By eliminating the operational complexities, OCI Container Instances enable users to run containerized applications without having to manage any infrastructure. Users only need to supply the container images for their applications, and OCI takes care of the underlying container runtime and compute resources. The containers are hosted on fully managed compute infrastructure that's specifically designed for container workloads, providing robust workload isolation for enhanced security. Optimized for container workloads, a container instance is isolated at the hypervisor level and doesn't share the underlying OS kernel or CPU or memory resources with any other container instances. With this second layer of defense, containers of different applications no longer share the same OS kernel, which reduces the attack surface. To wrap up, Oracle Container Instances provide a flexible and scalable container runtime environment that can run on demand without requiring any pre-provisioned infrastructure, making it a convenient option for containerized workloads in the cloud. I hope you found the lesson useful. Thanks for watching. Hello and welcome. I am Mahendra Mehra and I am a senior training lead and evangelist with Oracle University. Let's take a look at some of the features and use cases of OCI container instances. Alright, it's time to get started. Let's discuss the first feature, which is the serverless experience. OCI container instances run your containers on serverless compute, which is optimized for container workloads. The underlying infrastructure is fully managed and hardened by OCI. You can focus on building your applications without having to worry about provisioning, patching, or managing any kind of servers. Simple pay-per-use pricing. You only pay for the CPU and memory resources allocated to your container instance at the same price as the regular compute instances for the chosen shape. There are no additional charges or tax for the seamless operations provided by the serverless platform. No costs are incurred when the container instance is not active. That is, a container instance will be inactive as soon as the containers within the instance stop and the auto restart policy is not enabled. Let's understand how simple, fast, and flexible are OCI container instances. Easy to run with flexible configuration. Running a new container instance with one or more containers only requires a few simple parameters via CLI, API, or the OCI console. You have the flexibility to specify your preferred shape such as E3 or E4 flex, CPU and memory resources required, and the networking configuration. You can also configure environment variables, startup options, resource limits, etc. for each container. This enables you to launch containers instantly, configured just the way you want them to support your needs. Maximum CPU and memory. You can allocate all the CPU and memory provided by the underlying compute shape to a container instance to run even the most demanding workloads. For example, you can allocate up to 64 cores, which is around 128 vCPU and 1024 GB of memory to a container instance with the E3 and E4 flex shapes. Open Container Initiative compliant. OCI container instances support pulling container images from Open Container Initiative compliant container registries. It also includes the OCI Container Registry. Talking about security, networking, and observability. Strong isolation. Container instances provide a dedicated environment with strong isolation to each container instance, same as virtual machines. Containers running on a container instance do not share OS kernel and CPU or memory resources with other container instances. This enhances your application's security posture without compromising on its performance. You can also set up OCI Container Registry with private access and enable the security scanning for your container images. Integrated networking and access control. Each container instance is connected to a subnet in your VCN, ensuring secure communication. You can optionally assign a public IP to a container instance if the container needs to be accessed publicly. The containers on the instance share the same networking namespace. They can find each other on the localhost or 127.0.0.1 IP address. Using OCI identity and access management, you can configure policies to control access to other OCI services or resources from the container instances. Logging and monitoring. Using the built-in logging, you can view your container logs in the OCI console or pull them using the API. OCI container instances also provides built-in metrics to monitor CPU and memory utilization, disk I/O, network receive transmit bytes, etc. Now let's cover some of the common use cases for OCI container instances. Container instances are useful for running containerized workloads without a container orchestration platform like Kubernetes. They are great for short-lived tasks such as build and deployment jobs, automation tasks, and data or media processing. With container instances, running a container is easy with an API call or a CLI command, making it ideal for DevOps, operations, and data processing workflows. Container instances can also run isolated web applications or RESTful APIs, allowing you to use your preferred framework for development. Applications can be packaged as container images and run individually or in a group. Containers on the same instance communicate over localhost or the loopback interface, allowing for full stack application deployments and sidecars. Container instances can assist with migrating legacy monolithic applications to the cloud, which are typically not designed for cloud native platforms like Kubernetes. By containerizing these applications, you can run them on container instances without the operational burden of managing servers or virtual machines. Additionally, you can allocate the necessary CPU and memory resources to meet the demands of even the most resource-intensive applications. Container instances allow for quick creation and removal of development and test environments, replacing the need for local workstations or virtual machine management. This increases the productivity and reduces the resource limitations and potential risks. It's also useful for setting up test backends needed for application development and testing. To wrap up, in this lesson, we covered some of the key features and best use cases for OCI container instances. I hope you enjoyed the lesson. See you in the next one. Thanks for watching. Hello, I am Mahendra Mehra, Senior OCI Instructor with Oracle University. Welcome to our lesson on working with container instances in Oracle Cloud Infrastructure. In this lesson, we will explore the key concepts and features you need to know to effectively manage container instances. Let's jump right in. Before we dive into the details of container instances, let's first discuss IAM policies. IAM policies in OCI govern access to container instances and define permissions for different users or groups. These policies control who can create, modify, or delete container instances within your tenancy. As you can see, there are two different individual resource types that you can choose from. One is compute-container-instances. The other is compute-containers. These two individual resources can also be clubbed as aggregate resource type under the compute container family. There are different permissions associated to different level of access. For example, inspect level of access provides you only with inspect permission, whereas read allows you both inspect and read permissions. In the case of use level of access, you get inspect, read, update, start, stop, and restart permissions. Whereas with the manage level of access, you get the access to all the permissions that are listed out here. Also make a note for compute-container-instances, all permissions will have prefix compute_container_instance followed by the permission name. For example, the inspect permission here will be defined as compute_container_instance_inspect. Talking about the compute container individual resource type, here as you can see, the permissions are different as compared to the one we saw in the previous slide. You get inspect, read, update, log retrieve, create and delete permissions based on different level of access such as inspect, read, use and manage. Also make a note, all the permissions here has prefix compute_container, and for example, for inspect permission, it will be defined as compute_container_inspect. Understanding the policy syntax is essential for effectively managing access to container instances. Let's look at some of the examples. I'll be presenting some of the examples of policies that can be used when interacting with container instances. Depending on the use case, this resource type can be aggregate or individual. For example, if you want to let the users do everything using container instances which is launched within the cloud network and subnets in the compartment ABC, these are the list of IAM policies which you must have in place. You must allow your user group to manage compute container family in compartment ABC. The other permission is to allow group to use virtual network family in compartment ABC. The third permission is to allow your group to read repos in tenancy. Another example is if you wish to control the access to container instance using network security groups, the user group should be allowed to use network security groups in the given compartment. For example, here the statement defines we are allowing container instance launchers group to use network security group in compartment ABC. So basically, if you're planning to control traffic to and from your workloads within the container instances, you must have this particular policy in place that allows you to use network security groups within the compartment. Now another example is if you want to allow container instances to pull images from container registries, private repositories, we will have to implement access policies at tenancy level, for which the first step is to establish a dynamic group for your container instances, and to do so you will have to use the following syntax. All in curly braces you have to specify resource.type equals to compute container instance, and then you will have to allow your dynamic group compute container instance dynamic group to read repos within the tenancy. So you will have to write the following policy which allows the dynamic group we just created in step 1 to read repos within the tenancy. These actions will enable seamless image retrieval, streamlining the deployment process for containerized applications. Another use case would be to ensure the container instances have necessary permissions to access vault secrets for image authorization. In this case, we need to set up appropriate access policies. Well, firstly, you'll have to create a dynamic group encompassing all the container instances which are requiring read permission. So in this case, we have specified the rule as all resource.type and provided the name compute container instance. And the name of the dynamic group is container instance dynamic group. Next, we establish a policy granting the dynamic group read permission to the specific vault secrets. For instance, the policy statement allow dynamic group container instance dynamic group to read secret bundles in tenancy enables the group to access all vault secret bundles within the tenancy. Overall, if you want container instance to pull container image from your private repositories, you'll have to first store your credentials as secrets within OCI Vault and then allow OCI container instances to read those secret bundles within the tenancy. It is important to note that these policies provide broad access by default. However, you can utilize standard IAM policy mechanisms to refine the permissions, such as restricting access to specific container instances or secrets within the compartment instead of tenancy. Let's take a look at container instances shape that are managed by OCI. In OCI, container instances offer various shapes, each designed to suit specific workload demands. You have the choice of CI standard E3 flex, CI standard E4 flex, and CI standard A1 flex shapes. One standout option is the flexible shape, granting you the freedom to adjust number of OCPUs and memory allocation when initializing your container instance. This adaptability empowers you to fine-tune performance and cost effectiveness by aligning the container instance precisely with your workload requirements. Each of these shapes features extended OCPUs, allowing you to create container instances with cores that surpass the standard limit. Additionally, the network bandwidth scales in correlation with the OCPUs, ranging from 1 Gbps per OCPU to a maximum of 40 Gbps. Every shape includes 15 GB of ephemeral storage and one virtual network interface card, also known as VNIC, for seamless integration into your infrastructure. Now let's understand what is this concept of extended OCPUs. Extended OCPU container instances are designed for demanding workloads that need more cores than the standard configurations. With extended OCPU container instances, user can exceed the regular core limit, accommodating high performance applications that require additional processing power. You can create container instances with extended OCPUs to tailor resource allocation to the specific needs of your workload, ensuring optimal performance. However, it's important to note that due to the increased core count, container instances with extended OCPUs may take longer to create compared to instances with standard configurations. Well, let's discuss ephemeral storage. Ephemeral storage is shared storage allocated to a container instance and its containers. It plays a crucial role in various aspects, such as storing container images and supporting containers root overlay file system. Monitoring ephemeral storage usage is important for managing resources effectively. You can access this information through the OCI console, where you will find metrics related to ephemeral storage usage. And this is available within the container instance details page. Ephemeral storage capacity plays a critical role in supporting various resources within container instances. Let's explore the key components that consume ephemeral storage. Starting with container images. Firstly, container images utilize ephemeral storage to download, unpack, and prepare for deployment on a container instance. It is important to note that the amount of free space required can be up to twice the size of the container image. For example, with a default ephemeral storage capacity of 15 GB, container images should ideally be less than 7.5 GB to ensure successful deployment. If there's insufficient free space, the creation of a container instance may fail. Secondly, container logs are another consumer of ephemeral storage. Each container retains up to 20 MB of log files, contributing to the overall usage of ephemeral storage. Additionally, the container's root overlay file system relies on ephemeral storage for file backups, ensuring data integrity and reliability. Moreover, empty dir volumes can utilize ephemeral storage as backup storage, providing temporary storage solutions for container data. Finally, internal system processes within the container instance also utilize a small portion of ephemeral storage to support essential system operations. and we will continue exploring container instances in the next lesson. I hope you enjoyed this lesson so far. See you in the next one. Thank you for watching. Welcome back. Let's continue exploring container instances from where we left off in the previous lesson. Moving on to the container instance creation wizard, let's explore the creation basic details section. Under networking, you will configure the network details for the instance. This includes specifying virtual cloud network and subnet where the instance will be created. You have the flexibility to choose whether to use an existing VCN and subnet, create a VCN or subnet, or enter the OSID of an existing subnet. You also have the option to assign a public IPv4 address to the instance. This is useful if the subnet is public, as it allows the instance to be accessible from the internet. Additionally, you can access advanced options by clicking Show Advanced Options. Here, you can configure settings such as using network security groups to control traffic, specifying a private IPv4 address, assigning a DNS, and setting a hostname for DNS within the cloud network. Under the Advanced Options tab, you can specify the following settings. Firstly, the graceful shutdown timeout allows you to set the amount of time the container instances waits for the operating system to shut down before powering off. Next, you'll choose the container restart policy. You have three options to select from. If you select always, containers always restart, ensuring they remain running even after successful exits. This is useful for critical services like web servers. If you go for never, containers never restart, regardless of the reason for their exit. If you choose on failure, containers restart only if they exit with an error, ensuring that specific tasks complete successfully. You can also add tags to the container instance under the Tags tab. Tags provide metadata to help organize and manage your resources effectively. You can apply both free-form tags and defined tags provided you have the necessary permissions. Let's now dive into configuring containers for your container instances. Firstly, you'll need to enter a name for the container. This name doesn't need to be unique, as each container is uniquely identified by its OSID. However, it's advisable to avoid entering confidential information for security purposes. Next, under the image section, you'll select the container image for your container. You have multiple options for the image source. One of the options is to use OCI Container Registry, that is Oracle Managed Registry, for storing, sharing, and managing container images. The other option you have is to choose External Registry. It uses images from the third-party vendor such as Docker Hub. Here you must specify the registry hostname, the name of your repository, tags if any, and based on if it's a public or a private registry, you can go for none, basic, or OCI Vault Secret credentials type. Like I said, the Vault Secrets for image pull authorization securely manages credentials for private registries or repositories using OCI Vault service. In your use case, if you're pulling images from a private repository and if you want your credentials to be stored securely, in that case, you can use the Vault Secrets for image pull authorization. Additionally, you can set environmental variables for the container under the Environmental Variables section. These variables customize the container's execution, allowing for greater flexibility. For example, you can specify variables like nginx_port to customize your nginx behavior, or mysql_password to customize your MySQL containers behavior. Let's continue configuring containers for your container instance. On the Resource tab, you have the option to fine-tune the amount of resources allocated to the containers. You can specify resource limits in absolute or percentages, providing flexibility in resource management. Remember, by default, the container can utilize all available resources in the container instance. If you want to restrict the amount of resources that the containers consume, be it your vCPUs or memory, you must choose the Enable Resource Throttling option and then provide an absolute or percentage value to split resources amongst the containers. Moving on to the Startup Options tab. Here you can configure additional settings such as working directory, command and command arguments. These settings allow you to customize the startup behavior of your containers, ensuring it behaves as expected upon initialization. Lastly, on the Security tab, you can specify security settings for the container. Let's take a closer look at the Security tab and the various options available. Firstly, you have the option to enable read-only root file system, which restricts the write access to the root file system of the container. This enhances security by preventing unauthorized modifications to critical system files. Next, you can select the Run as non-root user option to ensure that the container does not run with root privileges. When enabled, the container runs with a specified user ID and group ID, enhancing security by minimizing the potential impact of security vulnerabilities. It is important to note that when using Run as non-root user, the user ID cannot be set to 0, which is for the root user. You can set the values for user ID and group ID anywhere between 1 to 65535 if Run as non-root user is enabled. You can also configure Linux capabilities for your container under Configure Linux Capabilities. Here you have the flexibility to add or drop specific Linux capabilities as needed. By default, the container launches with several capabilities, which you can choose to drop to further enhance security. Now, before we move ahead, let's take a look at some of the important points which are good to know when working with container instances. First thing is setup of IAM policies. Appropriate IAM policies should be assigned to user groups which are dealing with container instances. When creating a container instance, make a note you can create a maximum of 60 containers on each container instance. When it comes to managing container instances, you can start, stop, and restart a container instance. Container instances use standard shapes which pause billing when a container instance stops. Talking about metrics, you can monitor the health, capacity, and performance of your OCI container instances by using various metrics which are available under the Container Instance Details page. A point to note when deleting a container instance is when the containers are deleted by the service, any data on the ephemeral storage is lost. To wrap up, in this two-part series of working with container instances, we covered the IAM policies and other configuration settings necessary to configure the OCI container instance service. I hope you enjoyed watching these lessons. Stay tuned for the upcoming demos. See you in the next one. Thank you for watching. Hello and welcome to this demo on deploying a fully functional WordPress site using OCI container instances. I am Mahendra Mehra, Senior OCI Instructor with Oracle University. In this demo, we will take a close look at how to get started with the Container Instances service and its various controls to quickly and easily launch and manage container workloads on Oracle Cloud Infrastructure. We shall create a fully functional WordPress site by running both the WordPress container as well as MySQL container in the Container Instance service. The WordPress site image will be pulled from the third-party container registry, which is Docker Hub, while the MySQL container image is hosted on the OCI container registry, also known as OCIR. So let's get started. I've signed in to my Oracle Cloud account and this is my OCI console. The first task is to create and configure a container instance. I'll click on the hamburger menu and click on the developer services. Under containers and artifacts, I'll click on container instances. This opens up the container instances service page. Under the compartment section, I will ensure to choose the right compartment where I wish to create my container instances, and in my case it is CTD-OKE compartment. I will now click on the Create Container Instance button. This opens up the container instance creation wizard, and the first step is to add basic details for our container instance. Let's give our container instance a suitable name. I'll remove the timestamp here and just give it a suffix as demo. I'll make sure that the right compartment is selected for the container instance creation, which is CTD-OKE. The placement options include the availability domain you would like to place the container instance in, and as well as the option to choose a fault domain of your choice. I'll go ahead with the default selection, which is availability domain 1, and if you wish to select your fault domain, you must click on Show Advanced Options. Under the fault domain options, you can select the fault domain of your choice, or you can let Oracle choose the best fault domain for you. I'll select the first option, which is let Oracle choose the best fault domain. Moving on, we have to choose the shape. Basically, a shape is a template that determines the number of CPUs, amount of memory, and other resources allocated to an instance. By default, the shape selection is CI standard E4 Flex with 1 OCPU and 16 GB memory. However, you can customize this shape by choosing from various options available. To see the various other options available, we'll click on Change Shape button. This opens up Browse All Shapes window where multiple options are presented. This includes AMD, Ampere, and other shapes. As I mentioned, the default selection is AMD CI standard E4 Flex. You can opt for ARM-based processor where the option is CI standard A1 Flex, and under more shape options, you have the option to select CI standard E3 Flex. All of these shapes are flex shapes, allowing easy customization of OCPUs and memory for your containerized workloads. For example, if I select ARM-based processor, where I have the option to select CI standard A1 Flex shape, I can change the number of OCPUs from 1 to 16, and based on which the amount of memory will also change. Additionally, there is an option for extended OCPU. When the number of OCPU is set beyond the standard limits, the instance becomes an extended OCPU instance. The standard limit for ARM-based processor is 1 to 16 OCPUs, but if we extend the number of OCPUs beyond 16, it becomes an extended OCPU based instance. Remember, although container instances with extended OCPUs may take longer to create, they are beneficial for high demand workloads requiring more cores than standard limits. And remember, the extended OCPU option is available under all shape series. If I select AMD, the default range or the standard limit is 1 to 8 OCPUs, but if we extend the OCPUs beyond 8, it becomes an extended OCPU. For this demo, I'll be selecting ARM-based processor and change the number of OCPUs to 4. And the amount of memory, as you can notice, has been adjusted to 24, as for each OCPU, you can select up to 6 GB of memory. You also have an option to downgrade the amount of memory if you don't want the automatically adjusted value. Let's say I select 12 over here. I'll click on Select Shape. And as you can notice, the shape information has been updated. We are using CI standard A1 Flex with 4 OCPU and 12 GB memory. Next, we have to define the networking configuration. This lets you choose the networking options like VCN and subnet you want your container instances to be on. You have the option to select existing virtual cloud network, or you can create a new VCN on the fly or enter the subnet OSIT for an existing subnet. In our case, I already have a VCN created which I'll be reusing, which is CI demo. Under the subnet, I'll select the existing subnet, which is a public subnet. And if you wish to access your container instances using public IPv4 address, we must select the Assign a public IPv4 address option. Under Show Advanced Options, we have different tabs. Under the Advanced Options, you can select the Use Network Security Groups to control traffic going in and out of your container instances. You also have an option to enable Source Destination Check. By default, every VNIC performs the source destination check on its network traffic. The VNIC looks at the source and destination listed in the header of each network packet, and if the VNIC is not the source or destination, then the packet is dropped. You can also provide your private IPv4 address and set up DNS records. You can also assign a host name for your container instance, but these are all optional. For now, I won't be using any of these, so I will click on Hide Advanced Options. And under the Show Advanced Options at the container level, you have the option to specify the graceful shutdown timeout in seconds. This is the time given to the containers within a container instance to gracefully exit when the container instance is terminated. I'll set it to 30 seconds. You can also set a container restart policy to automatically restart containers that exit or terminate, or base the restart policy on the exit status of the container. For example, if I select On Failure, so whenever my container fails in the container instance, it will try to restart the containers. I will now click on Next. We have covered a lot in this session, but to keep things focused, we will continue exploring in the next video. So stay tuned and I'll see you in the next video. Welcome back. Let's continue from where we left off in our last session. Now it's time to define the first container in the container configuration section. In this example, as I mentioned, we will start with the WordPress container. So I will name the container as WordPress. In the image section, we'll have to select the image. Like I said, you get two options to select the image from. If I click on Select Image button, I have two options. One is OCI Container Registry and the other one is External Registry. So for the WordPress site, we will be using an external registry and we'll be pulling the official WordPress image from the Docker Hub. So I'll provide the registry hostname, which is docker.io, and the repository name is WordPress. Here specifying the image tag is optional and it defaults to the latest. So in our case, it will pull the latest WordPress image from the Docker Hub. Under the registry credentials type, the default option selected is none. But if your registry or repository you're using is private and requires authorization in order to pull the images, you have two choices. One is Basic Authentication or OCI Vault Secret. With Basic Authentication, you just put your credentials in the username and registry password fields. And with the OCI Vault Secret, you first save your credentials in the OCI Vault service and then use them for authentication. But remember that OCI Container Instance Service must have permissions to read the vault secrets provided for image authorization. I've already covered the IAM policies required for container instances in the previous lesson. You can either create the secret using the OCI Vault service and select the secret from the options available here. Since we don't have a secret already created, you can also select the Create New Secret and create the secret on the fly. This opens up the Create Secret window, and here you need to just specify the name of your secret, give it a description, select the master encryption key that you'll be using to encrypt your secret, and provide your registry username and password in the fields given. Once you click on Create Secret, the secret is created and that secret is used for authorization to pull the image from the private repository or registry. In our case, the WordPress image that we are using for this demo is available as public image in the Docker Hub repository, so we won't be needing to create a secret. I'll click on Cancel here and go back to the first option, which is None. and click on select image. Now let us set some environmental variables to use this WordPress image, and this information is available in the official documentation for the image on the Docker Hub. I'll start creating environmental variables. The first variable is WordPress _db _host, and the value is 127.0.0.1. I'll click on add another variable, and now it's time to add WordPress DB user. The value I'll specify is WordPress. I'll click on add another variable to add the password, which is WordPress _db _password, and provide the value as WordPress. Click on add another variable and add the DB name, which is WordPress _db _name, and name RDB as WordPress. So with this, I've set up the environmental variable required to set up our container instance running WordPress image. Also remember, when you have multiple containers within a container instances, just like in our case, we have one WordPress container and we'll be creating another MySQL container. They will share the same compute resources like CPU and memory that are available to the container instance. In our case, it's 4 CPU and 12 GB memory. Also, they share the same networking namespace, which is why the WordPress container can connect to the MySQL container over localhost or the loopback address, which is 127.0.0.1, as we have configured in our environmental variable. Now let's look at some of the advanced options. I'll click on show advanced options. Under the resources tab, you have an option to restrict the amount of resources that the container consumes. And remember, by default, the container can use all resources in the container instance. So to avoid one container from utilizing too much of these resources and starving other containers in the container instance, we can throttle the resources made available to each container by selecting enable resource throttling option. I'll select the percentage option and throttle the value of vCPUs and memories to 50% for this container, which means the WordPress container will only be able to use 2 OCPUs out of the 4 OCPUs that we have allotted to this container instance, and also limit the memory size to 6 GB out of the total 12 GB that we had allocated to the container instance. Under startup options, you have the option to override some image defaults like the working directory, the command, and the command arguments. And these options are available for each container under the advanced options. For WordPress site, we won't be changing any of these details. On the security tab, you can enable or specify security settings of the container. If you check the enable read-only root file system, this will apply read-only access to the root file system of the container. If you check run as non-root user, this will ensure that the root user doesn't run the container. When you enable run as non-root user, the user ID value cannot be 0. It must be a number between 1 to 65535. And if I uncheck this, you can use the user ID and group ID combination to run the entry point process of the container. The value for user ID and group ID must be an integer between 0 to 65535. And if no value is specified, the default value is 0, which stands for root user. Only once you set the user ID field, the group ID field gets active and you get to specify the group ID. Under Configure Linux Capabilities section, you can configure Linux capabilities for your container. By default, the container launches with several capabilities that you can choose to drop. Both add capabilities field and drop capabilities field support all value, which allows to drop all capabilities or add all capabilities that are enabled by default. And if you leave both the add capabilities and drop capabilities blank, all default capabilities are available for your container. if you enter all in the add capabilities field, all capabilities are available except those that you list in the drop capabilities field, and ignores all in the drop capabilities field. And if you enter all in the drop capabilities field, the container contains only capabilities that you list in the add capabilities field. For this demo, I won't be needing these features or capabilities, so I'll remove them, and would want my container instance to run as root, so I'll remove the user ID and group ID. With this, we've completed setting up the container values for our WordPress container. Now we'll go ahead and create another container by clicking on Add Container button over here. We have covered a lot in this session, but to keep things focused, we will continue exploring in the next video. So stay tuned, and I'll see you in the next video. Welcome back. Let's continue from where we left off in our last session. Now our WordPress also requires a database to function, and in this demo we shall run a MySQL database as a second container within the container instance. Let's give this container a suitable name. I'll click on Select Image. In the interest of time, I have already pulled a MySQL image and hosted it on the Oracle Cloud Infrastructure Registry. I will quickly go ahead and show it to you. I'll duplicate this tab and click on the hamburger menu, go to Developer Services and click on Container Registry. Now under my CTD OKE compartment, if I click on the drop down for repositories and images, you can notice I have a MySQL repository which is public, and there's a MySQL image hosted on it with the tag 8.0.31. Now I'll switch back to the previous tab, and here I'll select the first option, that is specify an image from an Oracle Cloud Infrastructure Registry, which is OCIR. I'll select the repository name, which is MySQL, and also select the image in the repository. The only image that's available there is 8.0.31. I'll click on select image. As you can see, it rightly reflects that it's pulling an image from OCI container registry, and this is the path to the image. Now I'll go ahead and set up some environmental variables to initialize the database. The first variable that I'll be setting up is MySQL root password, and the value is WordPress. I'll click on add another variable, and I'll set up the MySQL database, which again is WordPress. Now I'll go ahead and set up MySQL user using the key MySQL_user, and for the sake of simplicity, I'll give it the value WordPress. Click on add another variable and set up the MySQL password, and again provide the value as WordPress. I'll go ahead and click on show advanced options, and similar to the WordPress container, I will be enabling throttling for this container too. I'll click on enable resource throttling, select the percentage option, and set the throttling to 50% both for CPU as well as memory. So which means out of the 4 OCPUs that I had configured for this container instance, 2 will be used by WordPress container and 2 OCPUs will be used by MySQL container. And likewise for the memory, out of the total 12 GB memory that I had reserved, 6 GB will be used by WordPress and 6 will be used by MySQL. Under the startup option, I will set up the parameter to override MySQL container's entry point argument. So in the command arguments field, I will set up the value as this plugin called MySQL native password is a traditional authentication method used by MySQL servers to authenticate users. When this flag is set, MySQL will accept clients to provide passwords in the hashed format accepted by MySQL native password plugin during the authentication. This flag ensures compatibility with older MySQL clients and applications that accept this authentication mechanism. Remember, MySQL native password authentication plugin is not recommended in production environment. We have more secure and better alternatives that are available. Now I will click on next and review all the information. I will just cross-check all the information that we had configured to create these container instances. So as you can see, the name of our container instance is container instance demo. It's using the CI standard A1 flex shape. The availability domain is phx81. Under networking section, we can confirm that it's using an existing virtual cloud network, which is container instance demo, CI demo, and it will be assigned a public IPv4 address. Container 1 is WordPress container, which will pull the image from Docker Hub with the following environmental variables. And container 2 is MySQL container, which will pull the container image from OCIR repository as mentioned here. And these are the environmental variables with which it will be configured. Everything seems to be good. Let's go ahead and click on create. Well, as you can notice, the container instance is in creating state, and within a few seconds the workloads will be live. Let's scroll down. As you can notice, the container instance creation process is in progress. In the meanwhile, I'll click on containers, and we can observe that there are 2 containers getting created. And like I said, since we have enabled resource throttling, the CPU utilization limit for each of them is set to 2 OCPUs, 2 for MySQL container and 2 for WordPress container, as well as the memory limit is restricted to 6 GB per container out of the total 12 GB that was allocated to our container instance. Alright, our workload is now live, and since we chose to assign a public IP address to the container instance, we can use that to reach our WordPress site on the internet. I'll copy the public IP address. Now, one important thing to note here is that the ports that your applications listen on need to be allowed on the subnet security list or the network security group for an instance to be able to receive a connection. In our case, I've already configured the security list for the existing VCN that we are using, that is CI-demo. Let me go ahead and show it to you. I'll click on the subnet link and open it in a new tab. I'll click on the default security list for the VCN. Now, since our WordPress site is listening on port 80, I've configured the ingress rule to listen on port 80. If you notice, I have set up a rule to allow all incoming traffic on port 80. And this is essential for us to access the WordPress site using the public IPv4 address. Okay, I'll go back to the container instances page and copy the public IP address once again. I'll open up a new tab and try to hit the public IPv4 address. I'll go ahead and hit enter. Now, as you can see, our WordPress is live on the internet. Let me go ahead and do some quick installation process. I'll go ahead with the default language selection, which is English. Click on continue. Provide a suitable name for the site title. Let's say CI demo. Give it a username, which is provide a username for our WordPress installation. The password is auto-generated, so I will leave it to the same. Let's enter the email address. I'll copy the password and click on install WordPress. Now the WordPress has been installed successfully, I'll click on the login link to log into the WordPress site and use the saved credentials to log in. And there you go. With this, we confirm that the WordPress is live and the installation was successful. With this, we come to the end of this demo where we saw how to deploy a fully functional WordPress site using OCI Container Instances service. I hope you enjoyed the demo. See you in the next one. Thank you for watching. Hello and welcome to this demo on working with container instances. I am Mahindra Mehra, your senior OCI instructor with Oracle University. In this demo, we will cover basic administration tasks and learn how to monitor the health, capacity and performance of your OCI container instances. Let's jump in. I've already logged into my OCI console and this is my OCI dashboard. I'll click on the hamburger menu and go to the developer services, where I'll click on container instances, and from the list of container instances I'll select the one that we created in our earlier demo. Well, as part of administration, you can either edit the existing container instance info, that is, you can change your container instance name, you can stop your container instances, you can restart them, or you can start the already stopped container instances. Under More Actions drop-down, you get an option to edit your VNIC. You can move your container instance resources from one compartment to another. You can add tags to your container instances, or you can delete the container instance. Under the Resources section within the Metrics tab, you can monitor the health, capacity and performance of your OCI container instances. You can filter metrics based on start time and end time range, or you can use the quick select options. Choose any of the options from the drop down. You can view the CPU utilization metric, which gives you the % of container instances CPU resources that are in use. You can also view memory utilization, that specifies the % of container instances memory resources that are in use. Under CPU used metrics, you get the cumulative use of the container instances CPU resources since it was created, and similarly for memory used, you get the information on the amount of container instances memory resources that are in use. And towards the end, you get to see the ephemeral storage used. This is the amount of container instances ephemeral storage that is in use. Now, to get more detailed information about containers running within your container instance, you must select the containers link under the resources section. And here it lists you the containers that are created within your container instance. We had created 2 containers as part of our earlier demonstration. We have the WordPress container and the MySQL container running within this container instance. To get more detail about specific container, you must select the container from the list. I'll select the MySQL container. Here you get options to edit the name of your container. You can also view the entry point arguments that were set up at the time of container creation. In this case, we had set up the default authentication plugin to MySQL native password. You can also view any commands that were set at the time of container creation that overrides the command within the container image. In our case, there is no command that was set for this container. You can view the environmental variables that were set at the time of container creation. We had set up some environmental variables which are visible here. I'll click on close. And if you want to view logs of your containers, you must click on View Logs button. This opens up a window where you get to see the logs of your MySQL container. So in case you need to troubleshoot your container, you can always come and look at the logs. It will help you troubleshoot your container issues. You can periodically click on the refresh button to view the updated logs. I'll click on close here. And if you want to take a look at the metrics of your particular container, you can scroll down and look at the metrics such as container CPU used and container memory used. Also the container ephemeral storage used. These metrics are particular to the MySQL container. I'll go back to the container instance page. And like I mentioned earlier, you can click on the stop button to stop your container instance. But remember, it will first stop all the containers gracefully, and that depends upon the graceful timeout specified at the time of container creation. And if the containers take more time to stop than the graceful timeout allows, they are terminated by the container instance service, and any ephemeral data hosted by those containers will be lost. Remember, the billing depends on the shape that you use to create the container instance, and container instance use standard shapes which pause billing when a container instance stops. However, stopped and failed container instances continue to count towards your service limits. And before we wrap up, there's one more critical point to highlight. It's essential to note that the creation of your container instances may fail if the container image's architecture mismatches with the shape chosen for the deployment. So keep in mind that you cross-check the container image's architecture is compatible with the shape that you have chosen for the container instances. This will ensure a smooth deployment process. Thanks for joining us on this journey into container instances. I hope you enjoyed the demo. See you in the next one. Thank you for watching. Welcome to the world of Container Engine for Kubernetes.